Hi everyone, I'm Dr. Season and welcome to our course, Thermodynamics.
Today, we're going to discuss heat and specific heat capacity. What is heat? Heat is energy in transit. Heat can be defined as the thermal energy that is being transferred from one object to another because of temperature difference. Heat will always flow from hotter objects to objects with lower temperature. Now let us look at figure 2.2. So it shows that heat flows from region of hotter temperature to a region of colder temperature. Heat is also defined as the measure of the change in the total internal energy of a body. If the substance gives off heat, its internal energy decreases. It is important to remember that an object does not contain heat. Once heat energy touches another object, it is eventually converted into internal energy. When a substance absorbs heat, its molecules gain kinetic energy and move at a greater speed. The faster they move, the hotter the substance becomes. The substance is said to have gained internal energy. Internal energy is dependent on the amount of substance. The greater the amount of the substance, the higher is the internal energy. Now imagine yourself drinking a hot cup of coffee. As you drink, a tiny drop accidentally lands on your hand. The temperature of the drop of coffee is the same as the one in the cup. However, the effect is nothing compared to the effect of the entire cup of coffee poured into your hand. Here, it can be said that there is less internal energy in a drop of hot coffee than in a drop of a hot coffee. Internal energy is also proportional to the temperature of a substance. The higher the temperature, the greater the internal energy is. The most common unit used for heat is the calorie. The calorie is the amount of heat required to raise the temperature of 1 gram of water by 1 degree Celsius. A kilocalorie is 1000 calories. For food energy, the unit is also in calorie, but this time it is written with a capital C, which is a 1 food calorie or 1000 calories, or 1 calorie is a 1 kilocalorie. The relationship between mechanical and thermal work is called the mechanical equivalent of heat. The presently accepted result is a 1 calorie is equals to 4.1868 joules. Now, why do some objects remain hot for a longer period than others? So it is explained by the concept of heat capacity. Heat capacity is the amount of heat needed to raise the temperature of a body by 1 Kelvin or 1 degree Celsius. Heat capacity can be calculated using the formula below. C is equals to Q over delta T, where C is the specific heat capacity, Q is the amount of heat absorbed, delta T is the change in temperature. If 10 grams and 1000 grams of water are heated using the same heat source, it will take a longer time to heat 1000 grams of water at the same temperature change as that of the 10 grams of water. This shows that the amount of heat needed to change the temperature of an object depends on its mass. The larger the mass, the more heat is required. Since heat capacity depends on the mass, the amount of heat needed to change the temperature per unit mass can also be examined. This is a specific heat capacity. The specific heat capacity or specific heat of any substance is defined as the quantity of heat required to change the temperature of a unit mass of the substance by 1 degree. Different materials require different quantities of heat to raise the temperature of a given mass of a substance by a specified number of degrees. In short, different materials absorb energy in different amounts. From table 2.2, you will notice that water has a relatively high specific heat capacity as compared to the other materials, except for hydrogen, which is a flammable gas. The high specific heat capacity of water makes it a very good cooling agent. It means that a lot of heat energy is needed to raise its temperature. In most cars and manufacturing companies, Water is commonly used in cooling car and some machinery in most industrial companies. Similarly, the high specific capacity of water allows it to hold energy for a longer period. Hence, oceans are warmer in the evening while the sands of the beaches are cooler around at the same time. Since heat capacity depends on the mass, the amount of heat needed to change the temperature per unit mass can also be examined. This is specific heat capacity. Specific heat capacity can be calculated using the formula C is equals to delta Q over M multiplied by delta T. So let us proceed to problem example number 1. How much heat is needed to raise the temperature of 0.800 kilogram ethyl alcohol from 15 degrees Celsius to its boiling point 78.3 degrees Celsius? So we have here the given mass is equals to 0.800 kilograms, so you will convert that to 800 grams. For T sub F or final temperature, we have 78.3 degrees Celsius. For T sub I or the initial temperature, it is equivalent to 15 degrees Celsius. For C or the specific heat capacity is equals to 2.460 joules per gram degree Celsius. Substituting the given from our formula, delta Q is equals to MC multiplied by delta T, the answer will be 124,574.4 joules. That's all for now. Thank you and stay safe.